So, Vanakkam, we will continue our lectures. So, last class we have been discussing about the Indian seismicity. Okay, we have been discussing about some of the earthquakes, how the damage distribution was reported to understand what is the damage extent, what is the radius it affect, what is the this one. But we have observed that most of the earthquake we do not have direct record, okay, of the main shock. Most of the earthquake what we discussed, okay, even up to Killari earthquake. Okay. So, today class and then the subsequent classes we are going to talk about the tectonics of India. So, why tectonics of India? Because we have to understand where these earthquakes are origin, how it origin, so that there are some of the parameters which need to be considered or assumed for the seismic hazard analysis will be obtained from this kind of tectonic settings. Okay. So, if you look at the plate tectonics of entire globe, so you can see here, okay, so this is the plate tectonics of entire plate. So, this is basically your Indian plate, correct. So, this is the entire Indian plate, Indian Australian plate you can say, this is the Eurasian plate. So, this information you can obtain basically from this website, okay, you can see the related publication. So, where these maps are marked. So, here people have plotted earthquake, okay, of the magnitude 5 and above from 2002 to 2008, okay, above magnitude 5 for the 8 years. So, here you can see that, okay, so the depth of earthquake also mentioned, the red indicates 0 to 50, 50 up to 150, then followed by the yellow 300 and the green is 450 and 700. So, where you can see the subsequently the color composition of the these events will indicate a depth of earthquake occurring at this particular place. Okay. So, if you concentrate on the Indian region, which is very important for our discussion, okay, so the narrow band, okay, with shallow earthquakes marked in a red indicate that transformed boundaries or mid-oceanic ridges or divergent boundaries. Okay, so those are all the places where you get a very narrow, shallow focused earthquake, you can see. Okay, so this one, narrow band, there is no wide. So, the wider band, okay, so with earthquakes at range of depth or subduction zones. So, the wider band, the thicker band like this, okay, these are all the thicker, with the various depth of earthquakes are occurring in the subduction zones. So, wider band scattered earthquake marked continental. So, this is the one where you can see the wider band, okay, it's happening in the continental margin. Okay. So, particularly we have to concentrate on this place where Indo-Eurasian plate and continental rift zone are exist in this area, okay, which gives a plate tectonic evidence and the earthquake. You can see this earthquake, most of the earthquakes are located in the shallow depth and a few earthquakes, well, particularly this area. Okay. So, the earthquakes on this location and as well as this location where you have the slightly deeper earthquake. Okay. So, you can see again the plate tectonics in detail here. You can see this is the Indian plate. So, the arrow indicates like how much it moving towards this one, and also here you can also see the topography. Okay. So, like the mountains and this region and this like the agriculture or the plain where lot of agriculture is taking place. Okay. So, that this is the basically the separating, okay, portion of the your Australia and the Indian junction plate. Okay. So, this is below the sea basically. So, where you can see there was even an earthquake reported there, the arrow indicates here this one. So, here also you can see the movement, okay, so how the plates are moving. So, basically this is our Indian plate. Okay. So, the entire plate is called as Indo-Australian plate. The portion which comes separates, okay, so this is the Indian plate. So, it moves actually northeastern part. This plate moves northeastern part. Okay. The speed is given in millimeter per year. So, how much it moves, okay, per millimeter per year is mentioned as this one with related to the African plate. Okay. It is not the actual movement what is taking place with reference to the African plate, because the particular data what they used or extracted here was actually somebody was writing the African plate kind of studies. They related how the Indian plates is moving with respect to their plate. So that is how you can see this one. So this example gives, okay, so how our plate, okay, a different portion, how it behaves and moves, the details about your plate tectonics. So this you can even well relate with our continental drift theory. Okay, so we have seen that when we are talking about the continental drift, okay, theory, and then how the different continents are formed, you can see that about 170 million years ago, okay, this was the island, Madagascar island. You can see this is the South America and Africa together, and India, Australia, Antarctica are together. So same plate, you can see this is the Madagascar region. Okay, this is the South America and Africa. So where the India, Australia and Antarctica are separated, where the Madagascar is in between. Okay, so then it is this was actually 162 million years ago. So about 135 million years ago, so these three regions are completely separated. You can see South America and Africa, but still those two are not separated. Both the continents are together. The India and Madagascar are together, but Antarctica and Australia were separated. Those are together but moved from India. Then 100 million years ago, South America broken. Okay, it has went separate. Africa, India and Madagascar together, and Australia was different. So similarly, the South America, Africa, Madagascar, India. So this is about 88 million years. 60 million years the Madagascar moved close to the Africa, not anywhere close to India. So but India is island. Okay, so this evidence you can find from this website where they have made a detailed discussion about that. So here you can understand that when I am talking about the history of southern India, particularly when I discuss about the India, once it was a island, which is called as a Kumarikantam. Okay, so you can see that this was a island, okay, where the origin Indians were there, and even some people, Madagascar region and Africa, okay, so South America, they are all together by the races, okay, by their appearance, okay, with their DNAs, because these are all together at some time. So the people who are lived on 170 million year ago, their genes are carried by even a present generation. It has been proved, people are taken a DNA test and proved that these are all people sharing the similar DNA setup. Okay, so that is it proved that. So India was island about 60 million years. Okay, so then basically as we said that, so from the 60 million years, okay, so the India keep moving towards the northeast direction. Okay, so you can see here the India landmass 70 million years ago, this is the landmass island. So the India landmass 50 million years ago. Okay, then actually before that there is no Sri Lanka. Okay, the Sri Lanka was formed, okay, after 50 million years, you can see. So but even the maps they show together, but it's all graphical illustration, there is no detailed analysis kind of things. Here you can see that 71 million years, 55 million years, 38 million years, 10 million years and present. So this shows the India was continuously moving towards the northeast direction before hitting a Eurasian plate. After hitting a Eurasian plate, the speed has been reduced. That is what we discussed. So it was earlier moving with the speed of 20 centimeter per year. Now it is moving with the speed of 5 centimeter per year. So that is what you can see. You can see the formation of the India, where the India became an island, became a peninsula. Peninsula means 3 side water and 1 side land. Island means all the side you will have the water. So that was the evidence where you can see the geologically our terrain, okay, our landmass keep moved, tectonically keep moved, tectonically keep disturbed. Okay, tectonic forces are helping them to move. Okay, that is what you can see from this kind of evidence under the theories. So the northward moving Indian plate first collide with the south edge of the Tibetan Eurasian plate. So this continent-continent collision, okay, convergent boundary kicked up a Himalayan orogenic process. So that is a formation of mountain. Okay, Himalayan formation mountain started by the Tibetan Eurasian plate by the Indian plate hitting. Leading edge of the plate, oceanic crust carrying the India's subducted beneath the Eurasian plate, the landmass continental crust collide and pushing up a landmass. The collision continues even today. So based on the recent global positioning system, the India plate moves nearly 5 centimeter per year, about 2 inches growing in Asia, which is close to your nail growth. If you leave your nail without cutting, 5 centimeter per year it grows roughly. So that much our Indian plate is basically moving. However, GPS data also suggests that Tibetan plate pushes only about 3.2 centimeter, 1.3 inch into the Asia each year. So both of them are eating and then growing. Okay, that is what is happening actually. So this concept we can discuss that, as we told that, so the once the India was a island, so the related land, okay, so the Indian portion, this is the India, this is the portion which is sea floor, okay, water and sea floor. So this was keep moving like this. This is the typical graphical illustration of the before hitting the Eurasian plate. So the two tectonic plates collide into each other, the Indian plate oceanic crust being slightly denser and sinks under the subduct pull. So this Indian plate basically is slightly denser, because of that it gone down the above this plate, okay, which was a thin, which was above. So as the continent crust both the plate merges into one, the intervening oceanic sediment and rock get sandwiched between both the crust. Okay, so this is what happened here. Both the crust rock get sedimented, and this pushing, pulling, the piling up rock on top of the rock behind the Himalayan mountain, where the mountains are getting built up. You can see the mountains are getting built up on this place. So this is how this one. So that is the reason there are many sea fossils, okay, has been found in the Himalayan hill. Even though Himalaya is the highest hill in the world, okay, you can find a sea fossil. Sea fossil means a fish type, okay, turtle type, or any other sea animal, okay, their fossil has been found in the Himalaya. That clearly shows that the India was once island which is controlled by the, surrounded by the sea. That sea floor, due to hitting of that, the sea floor rising, and that raises whatever the animals who are lived there and it died and buried, that fossils are actually based. You can see the continent plate, and then the oceanic crust, how it goes, oceanic crust, then the sea crust, and all this, the complex fracture, okay, taking place, which help to Himalaya to grow. Basically this is the force which is taking place like this and like this, where it pushes and then this goes up. Okay, so this is basically the continental collision. Okay, so this converges the zones in the northern Himalaya. Whereas the continent collision, earthquakes are scattered over a much wider area, which we have seen that compared earthquake along the mid-oceanic ridges. So that is the evidence where you can see continent to continent collision. So where the area of earthquakes are wider, okay, because of the large land formation. Indian plate collided with the Eurasian plate, which we have seen. At one time, the India was separate continent. The oceanic crust separated India and Eurasian plate. At a time, subduction zone existed where oceanic lithosphere Indian subducted beneath the Eurasian plate, but two landmass finally met. They became locked together and subduction zone was closed. So earlier this Indian continent to continent close was subduction zone, okay, under a sea. But when the two landmass are hit together, the subduction is disappear, it became a continent to continent convergence zone. Okay. So subduction became a convergence zone in the geological age. Today the Indian plate is still pushing against the Eurasian plate. The region indicated by the red arrows in the figure in next. So where you can see how this pushing. So you can see here the earthquakes. Okay. So the collision accommodated transformed boundaries along the Indian plate. Regions are overall transformation indicated in the figure with the blue arrows. Okay, so this is basically, so the blue arrows. So you can see here basically this map. So this is how the Indian plate pushing, and this boundaries, okay, these are all the boundaries become a continent to continent subduction, and then now it become a, so the more or less like the convergent zone of action these regions, but this joins, okay, because of this action this is become a transformed boundaries, okay, the northeast and northwest of the plate boundary act in the action of transformed, okay, boundary action. So that we have to remember. The earthquake of magnitude 4.5 and above from 1990 to 2017, the researchers have plotted this. This was taken from this particular source. So where the collision zone between the Indian and Eurasian plate, you can see red line plate boundaries and red arrows collision zones, blue arrow transformed boundaries. You can see the wide distribution of earthquake. So when it comes to here, the distribution of earthquakes are almost like thin kind of things when compared to this size. Here you can see the wide distribution of earthquakes in that region. So they also marked some of the earthquakes which you have seen in the previously. This is the area where this map is plotted. You can see this. Okay. So the majority of earthquake in figure, okay, occurs at depth less than 70 kilometer. However, they are still abundant down to 150 kilometer, extend more than 300 kilometer depth at some locations. Okay. The deeper earthquake may be caused by the continued northwestern subduction part of Indian plate beneath a Eurasian plate. So the deeper earthquakes are happening due to the subduction action at the Indian and the Eurasian plate. So which is occurs very rarely because that subduction was there long back. Okay, even though area is no longer subduction zone, subducted slab still remains and subjected to stress can trigger a earthquake. So which indicates that there may be possibility of the subduction earthquakes also in this region. So apart from the active crustal shallow earthquakes, some earthquakes in the figure are related to the transformed fault either side of the Indian. So both the side of India basically we have the transformed boundaries. Most of the other areas related to the cruising caused by the continued convergent and Indian Eurasian plate. The cruising has occurred Eurasian plate to be thrust over Indian plate, building a Himalaya and a Tibetan place enormous height. Okay, these are all eating together and growing. That's why Himalaya is keep increasing there, right. Most of the earthquakes figure are related to the thrust fault shown in the this one, and the hundreds of other similar ones cannot be shown in this case. The southernmost thrust faults figure next slide, main boundary to the convergent boundary of the previous slide. So you can see here, so how the thrust fault formed due to this action, how these earthquakes are oriented. So the schematic diagram of Indo-Asia convergent boundary showing the example type of fault system is the earthquakes are focused. Okay, the fault system are you are focused. So these are all helpful to identify your ground motion prediction equation. Okay, what type of tectonic setting it has been developed, because as we have seen that the number of prediction equation developed for India is lesser when compared to its seismic activity. So that if you want to use a equation developed elsewhere, how do you consider? Okay, that is what is given. So the Himalayan are the convergent continent to continent boundary. They are continue to form because they are subduction zone along the whole east coast of Asia. Continental crust is free to move easternwards. Okay, so that is what it says. So you can see the cross section, typical cross section represented by preparing a graphics figure. You can see what are the like Terai, Silvax, Middle Mountain, High Mountain, High Himalaya, Tibetan plate, the Eurasian plate and Indian plate. Okay, how it moves, you can see here how it moves. All those information you can get. So from this, it is very clear that okay, our India is formed by hitting a two plate. So once it was a subduction zone, then now it's become a continent to continent divergence zone, convergence zone, continent to continent. So there is a possibility of active shallow convergent zone earthquake as well as the subduction zone earthquake in the region. Generally subduction zone earthquakes can occur very deep. Okay, so where 350-300 kilometer. Because of deep in nature, the seismic force released by these earthquakes are not much affect the cause damage. But at the same time, we should not ignore that. And then, but the earthquakes which is caused by the continent, so convergent action, which is a active tectonic shallow crystal nature. Okay, so most of the fault in the region thrust fault, both the eastern and western side we have the transformed boundaries, so where the earthquakes can occur. So this is about the, I am talking about the northern India, more on northern India. So I am not talking about the subduction zone of the Andaman Nicobar area. Okay, so that is also very important, but the number of island there was only so much cover. So our Indian landmass in this area was negligible. So because of that, we always year after talk about the peninsular India and our northern India and northwest and northeastern part of India and its related tectonic activity. So these are all we are going to discuss in the coming classes. Okay, we are going to talk about more on our Indian tectonic, this one particularly the areas where you can see this part. Okay, so this region we will be discussing and this region will be discussing, this region will be. So what are the different geological studies are done, how the tectonic people try to understand, and we try to also discuss about that, because our most of the populations are located on this part, even though this subduction zone also part of Indians tectonics, but we don't give much attention there, only we will concentrate much on here. So these settings will help you to identify what type of nature tectonic earthquakes are occurring, what depth it is occurring, what is the range of magnitude occurring. So those are all the information you get from the tectonic settings. So we will discuss this further in the next class. So thank you very much for watching this video. So I will meet you in the next class. Thank you.